And with us, we have Tadej Gabrijel, e-government expert in the IT Directorate of the Ministry of Public Administration from Slovenia. He has extensive experience in project management, IT system development, and policy making. In the Ministry of Public Administration, he is dealing with various projects and systems in the field of electronic services, data exchange, interoperability, and internal cooperation. So Tadej, the virtual floor is yours.
So, hello. I must say it is my pleasure to be able to talk today about the machine learning solution that we have implemented in our context of data exchange. It is a technical solution, but it is providing a solid basis for interconnection of our base registers, and it automates routine tasks to make data exchange more stable and reliable. It is running in production mode for 6 months now. In Slovenia, we have a central system for data exchange. It is a powerful, flexible, reliable solution, and it is being used extensively. It consists of 3 key building blocks: central brain called the tray, platform for standardized data distribution, I/O module, and the solution for asynchronous data gathering. Security platform is also an important building block for authentication and authorization used by many applications today. The system was originally developed for e-social security in 2012. The advantages of using these building blocks are clear and can be observed on various levels: transaction costs, reuse, governance, digitalization of processes and society. In the past years, we were honored to receive some important awards and confirmations for our system. That helped us a lot for the visibility and trust. Today, all social support procedures are using it, all public procurement procedures, e-government portal, anti-money laundering, anti-corruption service, and so on. Over 10 million transactions were processed last year. That's in a country with 2 million population. The solution has gained a reputation of a safe and efficient data exchange tool. Ministry of Public Administration is responsible for developing and maintaining the solution and for providing the services. We use various methods to ensure high uptake of the system. Today, we are faced with high demand for additional clients and data sources to be connected. So the system has become very mission critical on one hand. And on the other hand, its use is increasing, and we want to keep the good reputation by offering high performance and reliability, despite the uneven and unpredictable demand. In practice, the workload is not constant. Many systems are normally most active on workdays between 7 a.m. and 4 p.m. But in some cases, significant peaks can occur, potentially causing problems for the central infrastructure and also for the external systems like data sources, occasionally required to accept and process high number of inquiries in a very short time. On this picture, you can observe a typical daily pattern, weekly cycles, and specific peaks during a year. Last year, the ministry responsible for social affairs announced that it will now regularly, once a year, verify all the social beneficiaries if they still meet the criteria, and then either prolong or stop the social support. That is, useful and kind from the government, from the citizen perspective, but technically it can cause a big yearly tsunami of data requests, having to be processed in a very short time period. Technical capabilities are always limited, so we have to protect the system to be damaged from such peaks. Because besides the social ministry, other clients can also plan similar exercises. We are now in a situation where it is very easy and cheap to get the data. So there is less need to be careful and rational, and the data exchange scenarios can grow wildly. So clearly we had to do something. Besides the peaks, there is one more threat. Our tray has a very useful and precious auto-resume function. If a data source is temporarily unavailable, the system can try again and again with inquiries, and once the data source is recovered, the system sends it all the accumulated inquiries to process. In principle, such short disturbances are invisible to the client because the system compensates them automatically. But it is possible that if the amount of inquiries accumulated during downtime of a data source grows too big, it can cause additional problems for the data source, having to process both the regular traffic and the delayed traffic, potentially causing even more downtime. So we don't want our central data exchange solution to become a single point of failure. We want it to pay attention to the environment, to all the integrated systems. We want it to control the intensity of traffic going to certain institution, so the throughput can be maximized without the damage. We studied the real situations and events occurring in our data exchanges. Not all data sources get the same pressure. Time distribution varies, and sometimes data sources experience problems and we get errors. You see some peaks in these pictures. So if we observe performance in the long run, we can see some patterns and characteristics of data sources. Some of them have better performance, some are not available, for example, during weekend, some may be experiencing some technical disturbances, and so on. We can learn and adapt to these realities. We were experimenting some time, trying to capture the relevant information, to extract and observe the features and learn how we can best manage the whole situation. In November, we launched a system that is constantly monitoring the performance of integrated systems in real time, incrementally learning from its real-time big data flow, and using the knowledge to optimize the intensity of calls. We used traditional approaches to machine learning and tried with various algorithms. We observed that the future extraction and calculations are computationally intensive, so that cannot be performed inside the database. The machine learning system is implementing using the CRISP-DM machine learning scheme, and incremental learning is carried out using the algorithms available in the Java machine learning framework, Weka and MOA, allowing predictive modeling by flow data mining. So our central building block, the tray, can now use machine learning functionality for throttling the traffic. Based on the past and current performance of data sources, we can make the micro predictions in real time, allowing us to regulate the intensity and amount of calls. We are constantly learning from the current performance so we can incrementally adapt to the ever-changing situations. The system is running on our government cloud infrastructure, using modern concepts of microservices, containers, open API, and allowing automatic orchestration of upscaling, downscaling, rolling updates, and load balancing. There is also a dashboard for monitoring and micro-tuning the whole system. So with this learning and throttling system, we can now monitor and regulate the utilization of data sources. This ensures maximum throughput of the system, its stability, and the timely acquisition of data. The results of predicting the data source performance are higher average speed of data inquiries, better utilization of data sources, and minimum queuing. We have high stability, robustness, and technical sustainability ensured now. We have the ambition to further develop the solution. It could perform similar predictions and channel optimizations also in other contexts, to act like prediction as a service. By using open API interface, also other systems can use its functionalities. But it's not just for throttling. It can develop into a generic machine learning building block. But first, we need some more experience with it. We also need to define organizational and technical terms and conditions for using it, and to provide adequate resources for operations and support. That's very important before we offer it as a building block. If you want any additional information, you can write us, and some of the information is also published on the web. Thank you very much for your attention.
Okay, thank you very much, Tadej. To give people a little bit of time to think about their questions, maybe let me ask one myself. How long did this whole development take, and what were the main challenges that you've been facing?
Okay, the development took us about 6 months to develop, and it was really fast and efficient. We have a very good developer cooperating with us. It has also developed the original solution, our building block, the tray, and we developed the learning and throttling solution quite fast and quite efficiently. Main challenges were especially the big amount of data. We were experimenting a lot, and we had to use the production data. We couldn't use test system because the burdens, the amount of transactions in the testing environment are not big enough to give us real information. So we had to invent a way to extract the features from the production environment and to experiment with it. So it was a challenge. On one side, we had to respect the data security and the stability of the production environment, and we had to find the right technology to provide us enough processing speed and flexibility that we could do our experimentations. So that was quite interesting challenge.
Meanwhile, we have another question in a similar context in the chat box about the number of your of people in your team, your working method. Was it agile? Who is the project owner? And since we have only one more minute before going into the general question and answer, you may choose to also answer the other one. Who is now using the main outcome, who will use it in the future, or we might put that into the Q&A.
Okay, yes, the elements of agile development were present here. We were, of course, using every knowledge that we could use to produce the results very fast and very adaptable to the new observations and new possibilities that we encountered. And the amount of people managing the whole solution is not very big. We are a small country, so we have on ministry some people managing the building blocks, and together with our developers and the external partners taking care of the operations and upgrades and the stability of the system, we can manage to ensure the service levels that we have agreed with our clients. So who will use the main outcome? Our Ministry for Public Administration is responsible for providing these building blocks and to ensure it is stable and powerful. So we are the ones who are responsible for operations, but the users who will be gathering the data using this pipeline, they will be the main beneficiaries of these new features. They will have a more stable, more powerful tool, and they will be able to get their data in a faster time.
Okay, thank you very much.